My name is Hagai, I'm the CEO of Autotalks, and what I'm going to talk to you about is, again, we are in the auto track. What's happening on safety? How do cars start to communicate? So as people, we all talk to each other, but what happens when cars start to talk to each other for the sake of safety? So let me walk you through some of the things that technology can enable and share what's going to happen in the future. So first of all, who we are as a company. So we are a fabless company. What we do is we provide solutions, chipsets, a solution that is eventually a solution that provides this communication between vehicles. We are fabless, means that we manufacture this with partners, so we don't have our own manufacturing. And the most important part is the team. To do communication between vehicles is not just a regular communication between consumer devices. This is a highly safe, highly reliable environment if you want to use this for safety-related applications. So you need a very innovative and committed team that can know multiple domains when it goes to automotive. So safety, cybersecurity, communication, radio and algorithm, all that needs to be combined together if you want to provide the best possible solution. Offices, wherever we have customers, and we are backed by leading VCs in Israel. We recently completed a round of around another 40 million, and overall the company investment is 80 million. So to be in automotive, you need to have a long patience and also a long commitment to this market. So it takes time, but when you are there, it's a very lucrative market. So let's talk about the problem that we are trying to address and what's happening in this market. So we have three major pillars for this market and what we believe is driving. We had some previous people talking about congestion. So the three main things that happen in our industry is, first of all, fatalities and injuries. There are more than 1.3 million people dead every year from car accidents. There is actually a fatal accident happening every 15 minutes in the US. So while I'm talking here, there's going to be tens of people probably injured or a few even killed in car accident. That's the US only. And it's a global phenomenon and a global problem, and actually it's increasing and not decreasing because of our distractions, smartphones, mails, messages, etc. And the next big problem is, of course, mobility and transportation. So how can we harness technology to solve some of this congestion? And again, congestion not in public cars or autonomous cars, but congestion also for people who actually drive the cars, because it's going to be decades of an environment where it's going to be a hybrid environment. Manned and autonomous vehicles are going to share the same roads. So even if we resolve the congestion for ride sharing, we still are going to use the same roads. So how do we address that? And of course, the result is reduction of pollutions. So what do we essentially do? What the solution does? So imagine you're going to have X-ray vision, just like Superman's. I'm going to see through buildings. I'm going to see around corners. So the technology enables you through communicating of messages between all vehicles that share the road. So every vehicle shares velocity, speed, trajectory, path, acceleration, deceleration, position. So once that information is shared with the rest of the vehicle, every vehicle actually knows, has a perception of what's happening around him in those special cases where I don't see the object. So we have a lot of solutions in the market, cameras, LiDARs, all that now in vehicles. Mobileye is a great company, but they all imitate eyes, or even radars, they imitate feeling. How can we actually see what we don't know is coming in front of us? So when you hit the intersection and somebody's going to cross a red light or not obey a stoplight, once you're inside the junction, it's already too late. The accident already happened. So communication allows us actually to sense the future, to understand what's going to happen in the next 3, 4, 10, 15 seconds and actually prevent the accident from happening. So what we call non-line of sight conditions. Naturally, there are many other use cases that can go on top. So now we can discuss an environment where sensors are being shared. So I'm driving on the road and I have a car with a camera. I detect pedestrians. I announce to the rest of the people around me that pedestrians are crossing a road. And even if I'm a driver that comes from the right side, I'm going to be careful because I know there are pedestrians crossing there. Or even if I'm going on black ice or I'm sliding because I sense that my ABS is in motion or is actually activated, I can announce to other vehicles that are reaching this point, slow down. There's going to be a dangerous situation. Again, preventive is much more powerful than last-minute reaction, just like medicine. We want to have preventive medicine and not just cure diseases. Accidents, if you don't go into them or into dangerous situations, you can actually save a lot of lives. This is what is happening globally in the OEMs. We are naturally part of many of those programs. So VW is going to launch this on roads from 2019 in Europe. Toyota has launched this in Japan in hundreds of thousands of vehicles. GM in US, Ford, Renault, and many others actually announcing intentions to go for what they call cars to communicate between themselves. And communication is not just between vehicles, communication is between vehicles and their environment. So X stands for everything. So in the future, we are going to be able to exchange information with ourselves as pedestrians, smartphones or wearables, e-bikes, bicycles, motorbikes, everything will exchange information. This time, instead of infotainment, the target will be for the sake of safety. So all moving objects which share the road will exchange information for the sake of safety. This is what's happening in infrastructure. There was hundreds of billions of dollars or millions of dollars being spent globally on infrastructure. So the play is not just cars, it's also infrastructure. So I can now get information from the traffic light when it's going to change. I'm going to be able, as an emergency vehicle, to change the traffic light when I'm traveling to an emergency situation or when I'm traveling to the hospital. So all the optimization that were discussed by previous presentation about how do we optimize a city. Imagine a city that everything is connected to everything, and I sense each and every movement in cars on roads, and I can adjust dynamically whatever is happening on the traffic lights and road signs, and adjust accordingly and optimize the traffic that goes through the city. So that's going to be possible once we have this installed infrastructure, and you already see connected roads and an initiative all across the US in deployment of infrastructure into what they call connected roads. So what is this different from other sensors? So of course, if I start from the top, you know, fog conditions, ice conditions, we have so many scenarios which are difficult to address with cameras. So we need other sensors which can address those scenarios. So many cars in fog conditions cannot be detected by cameras or others. Being blindfolded by sun in early morning or late afternoon, or even intersection where things are crossing from the side of the road and cameras cannot detect them. So we are not saying that our sensor should be the only one, but it's an environment we have sensor fusion, where you fuse just like a human brain. If we were not to communicate, we have much less power to solve many problems. So cars, by having to do or to address all the problems by themselves, they are much less powerful than a human being. And just like a human being has a subbrain for communication, so will cars in the future. This is just a movie to show how we can also dramatically increase mobility. Can you press play? See if you go with the cursor, press play on it.
Take a one-lane highway with happy cars flowing until a chicken crosses the road. The driver who sees it brakes a little, the driver behind him doesn't notice immediately and brakes a little harder than necessary. The driver behind him does the same until someone comes to a complete stop. And oh look, cars approaching at highway speeds must now stop as well. Though the chicken is long gone, it left a phantom intersection on the highway. This is what's happened when you're stuck in traffic for hours thinking there must be a deadly pile up ahead, and then suddenly the traffic's over with no wreckage in sight. To your relief, if you're a good person, and mild annoyance if you aren't. You just pass through a phantom intersection, the cause of which is long gone. And this phantom intersection moves. It's really a traffic snake slithering down the road, eating oncoming cars at one end and pooping them out the other. On a ring road, a single car slowing down will start an Ouroboros of traffic that will last forever, even though there's no problem with the road. If the drivers could coordinate to accelerate and separate simultaneously, easy driving would return. But they can't, so traffic eternal. On highways, traffic snakes grow if cars are eated faster than excreted, and they shrink if excreted faster than eated, dying when the last car accelerates away before the next car must stop. Now, in multi-lane highways, there needs be no chicken to start gridlock. A driver crossing lanes quickly with cars too close behind is enough to birth a traffic snake that lives for hours and leagues. It's this quick crossing that causes drivers behind to overbrake and begin a chain reaction. But we can make traffic snakes less likely by changing the way we drive. Your goal as a driver is to stay the same distance from the car ahead as from the car behind at all times. Tailgating is trouble, not just because it makes accidents more likely, but because you as the tailgater can start a traffic snake if the driver ahead brakes. Always in the middle. Okay. This gives you the most time to prevent overbraking, but also gives the driver...
So I don't know who can stay in the middle in Israel or another other place, but to solve that, if we have communication with cars and we try it and we start driving cooperatively, we can make a dramatic change. So even with 10% penetration, we can dramatically reduce the length of traffic jams, and that will increase the level of efficiencies of using roads. And that's the last slide, sensor fusion. We believe that eventually a car needs to have multiple sensors, so it has eyes, it has feeling with radars. It lacks one very critical sensor, which is the communication sensor. And that's what we do as a company. So thanks very much.